Hi, this is Team Prismo. I'm Nasser.
I'm Sean.
My name is Eric.
I'm Aranza.
And we're here to present our intelligent video captioning algorithm. In the world of video captioning, video captioners have to manually place the positions of the captions on the screen. And what our algorithm does is it takes a VTT file with just timeframes and captions and transforms it and adds by adding positions to the captions, as you can see on the screen. All the user has to do is submit an MP4 video and a WebVTT file. Once they add those, they can adjust the weights of objects on the screen and how significant they are. Also, they can adjust the frames per second and enable scene detection. Scene detection is great for videos that changes scenes a lot. And once they do that, they can submit the form, and this is where the web server will run the algorithm.
So our algorithm can be divided into 3 phases. In the first phase, the program parses the input VTT file into a list of VTT queues and intervals. Any overlapping intervals will be merged. In the second phase, the program uses OpenCV and different machine learning algorithms to create heat maps, which in turn will be used to find ideal places to put captions. Besides implementing the general algorithm, I am also responsible for implementing text detection, which I did using East, which in turn uses a neural network to find the texts on an image. The program also penalizes the center because we don't want to put captions on the center of the video. In the final phase, the program generates an output VTT file that contains information about the positioning of each VTT queue. The web app acts as an interface to provide output VTT file to the users. It also places the captions into the video itself.
So let's take a little deeper dive into our algorithm. To generate these heat maps, we have various parameters to determine the ideal caption location. So I was involved with 3 detection techniques: motion detection, analyzing the number of frames, and scene change detection. With motion detection, the algorithm finds any moving objects or characters and returns information to not place caption at that certain positioning and time. Also, we can also analyze the video with various numbers of frames. If you want the best performance, increase the frame count so the algorithm has more samples to analyze. And if you want fast performance, decrease the frame count so there's fewer samples to analyze. As for scene change detection, a video may have a quick scene change, so our algorithm can determine various frames that, hey, there's been a drastic scene change, so a caption shouldn't be placed there.
And another major component of our algorithm was the facial detection algorithm. We use deep neural networks and train them to find human faces and weigh those areas in a frame more heavily than any other area. So using these heat maps along with the other algorithms, we were able to find the ideal places to put a caption to create the WebVTT file, including the positioning of where that caption should be. So this is a major improvement because previously it was done manually, and by allowing our users to have this flexibility, changing how many frames they can analyze or using another algorithm to detect those scene changes, we are able to allow our user to decide whether they value more efficiency, more accuracy, or if we could do something more efficient and accurate. That is our goal with this algorithm, since we are now have been able to automate it. And our results should be shown on our web app here. So here in the video player, we will be seeing our results of the WebVTT file playing on the video that was input. And we see the captions are being placed at the top of the screen here, where we are avoiding the face and the logo for Telestream. And finally, we have the VTT file download option right underneath, and that is our project.